Hello students, I hope all of you are safe at home. So today we are going to start with our next point, that is decimals. Okay, so what are decimals? Decimals are such numbers whose whole number part and decimal part is separated by a decimal point. Got it? So a decimal has two parts. See, the whole number part and the decimal part. Here I have given one example. See, for example 68.05. So on left side of the decimal point, whichever number is written, this is called as the whole number part. And on right side of the decimal point, the number which is written, that is called as the decimal part. Now we'll see note. A small note is given over here. See, all natural numbers, whole numbers, odd numbers, integers, etc. can be written as a decimal number. Means what? See, for example, if I want to write 5 in the form of decimal, so how can I write? See, here I have written, for example, 5 can be written as 5.0. Okay, you can put dot, that is decimal point, and after that you can add zeros, as many as you want. So each and every number you can represent in the form of decimals. One more example, let's see over here. I've taken here minus 13, right? So minus 13 also can be written as minus 13.0, or you can write minus 13.00. Got it? So all numbers you can write in the form of decimals. Similarly, every fraction also can be written as a decimal number, right? See, for example, I have taken over here half. That is 1 by 2. If I'll actually divide, I'll be getting 0.5. So fraction half we can convert in the form of decimals as 0.5. Now see second example. In second example, fraction is written as 3 upon 4, right? If I'll divide 3 by 4, I'll be getting 0.75. That means again we can convert fraction into decimals. Clear? See the third example. In third example, we have taken 3 upon 2. If I'll divide 3 by 2, I'll be getting 1.5. So that means every fraction we can convert in a decimals. Clear? Okay students, now we'll see expanded notation for decimal numbers. As you know how to expand whole numbers, like that only we'll see how to expand decimal numbers. So as we know that in decimals there are two parts, right? Whole number part and decimal part. Whole number part you can expand as you know, right? That means units place value you are multiplying over there by 1. Then tens place you are multiplying by 10, right? 100 place you are multiplying by 100. Similarly, what about now decimal places? So as you are moving from left to right after decimal point, the first digit after decimal point is multiplied by 1 by 10. That place is called as tenths place, right? TENTHS, tens place. That means the first digit is divided by 10. Second digit is divided by 100. That is called as hundreds place. Got it? Then thousands place. That means the third digit after decimal point is divided by 1000. And it goes on like that. So let's see one example. The expanded form of 147.2. Okay, see here how to write expanded form of 147.2. So 147 is a whole number part. So we'll write it as 100, right? Plus 40 plus 7, right? So that means we'll multiply 7 by 1, then 4 by 10 and 1 by 100, right? Now after decimal point, see how to do. So after decimal point, one digit is there, that is 2, right? That is the first digit. So we'll divide this first digit by 10. that is 2 upon 10. Now let's see one more example. Write the expanded form of 180.05. So 180 is a whole number part and a 05 is a decimal part. Okay, so 180 will expand as usual, that is 100. See here, 100 plus 80 plus 0. No need to write that. 0 into 1 makes 0. Okay, now see which are the places after decimal point. So first digit is 0. So what we'll do? 0 upon 10, right? The first digit will get divided by 10. Now second digit is 5. So that second digit will get divided by 100, right? So expanded form you can write like this also. That means 100 plus 80, right? Plus 0 upon 10, that makes 0, right? So no need to write that. So plus 5 upon 100. Now 5 upon 100 means 0.05. So we'll write the expanded form like that: 100 plus 80 plus 0.05. I hope all of you understood how to write the expanded notation for decimal numbers. Remember one more thing, that while you are writing a number in expanded form, we are always using plus operation, right? Okay students, now we'll see some types of decimals that are like and unlike decimals. So what do you think? What are like decimals? See here, from these examples you can understand. Here I have written 2.54, right? Then 3.29 and then 200.62. If you observe these three examples neatly, after decimal point, how many decimal places are there? Each and every example is having two decimal places, right? So like decimals means decimal numbers that have an equal number of digits after the decimal point. Got it? These are said to be like decimals. So what are unlike decimals then? Unlike exactly opposite to like. The decimal numbers that have unequal number of digits after the decimal point are called unlike decimals. See here, for example, 5.329, right? Then 200.4 and then 45.09. If you observe these three examples neatly, in the first example, three decimal places are there. In second, one decimal place, and in third, two decimal places are there. That means the number of digits after decimal points are unequal. Got it? So that's why these are said to be unlike decimals. Okay children, now just we saw the types of decimals, that is unlike and like decimals. So is it possible to convert unlike decimals to like decimals? Yes. But before seeing that, we'll see one property related to decimals. So which is that property? See, writing any number of zeros to the extreme right to the decimal part does not alter the value of the number. Means what? See here, for example, 35.91 is the same or equal to 35.910, okay, or 35.91000. That means we can add as many zeros as we want to the extreme right of the decimal part. It doesn't change the value of that number. So by using this property, you can convert unlike decimals to like decimals. How? See, unlike decimals can be converted to like by making number of digits in the decimal part equal. So how can we make number of digits in decimal part equal? By inserting zeros to the extreme right of the decimal part. We can convert them into like decimals. See here, for example, 42.39. And second example is 59.734. So you can see over here, in the first example, two decimal places are there. In second example, three decimal places are there. So obviously these are unlike decimals. But if I'll insert 0 after 39, in the first example. So it will become 42.390, right? And here the second will remains as it is, 59.734. Now these are like decimals, right? Why? Because their decimal places are equal now. So by this way, by this method, you can convert unlike decimals into like decimals by inserting zeros to the extreme right. All of you understood? Okay children, now we'll see the next topic, that is how to add or subtract the decimals. Actually, addition and subtraction of decimals is same as that of regular addition and subtraction of whole numbers. Okay, the difference is only that we are putting decimal point in addition and subtraction of decimals. That is the only difference. So where to put the decimal point? See, before adding or subtracting of decimals, first you have to convert them into like. That is important. First you have to convert them into like decimals. Then only you can add or subtract the numbers. Normally by putting the decimal point in the same place as the decimal column. Okay, now how to add or subtract the decimals we'll see in our exercise. So before moving towards our exercise, note down that solve mental maths which is given on page number 32 in textbook. Now you won't be having your textbooks, so you can solve on practice book also or HW also. Okay. Okay children, now you'll see exercise 2.3. First question, write the following decimal numbers in expanded form. So first one is 2.5081. So here whole number part is only 2 is there, right? And in decimal part 5081. Four numbers are there, four decimal places are there. So how to write in expanded form? So first number will multiply by 1, that is 2 into 1, that is 2. So first digit after decimal point, that is 5. So we'll divide 5 upon 10, right? First digit will get divided by first place get divided by 10. Second place will get divided by 100, that is 0 upon 100. Third place will get divided by 1000, that is 8 upon 1000. And the fourth place will get divided by 10,000. Now I'll convert these fractions into decimals. So first number will remain as it is, that is 2. 5 upon 10 means 0 0.5, right? 0 upon 100, that makes 0. Remember one thing, that 0 upon any number is always 0, so no need to write that. Okay, then next number is 8 upon 1000, so I'll convert it into decimals as 0 0.008. And next number is 1 upon 10,000, that is 0 0.0001. Now let's see the second example, 0.510101. Okay, so here in whole number part only 0 is there. So I'll write 0 as it is. First digit is 5, so it will get divided by 10. Second digit is 1 divided by 100, right? Third digit will get divided by 1000. Fourth digit will get divided by 10,000. Fifth digit will get divided by 1 lakh, right? Next digit will get divided by 10 lakh. Now I'll convert these fractions into decimals. So 0 no need to write over here. So 5 upon 10, that means 0 0.5. Okay. Then 1 upon 100, that means 0 0.01. 0 upon 1000, again no need to write this number. So 1 upon 10,000. So we can write 0 0.0001, right? So again 0 0.1 lakh. Again this number should not be written. Okay. Next number is 1 upon 10 lakh. So that number will write like this, 0 0.000001. Now we'll see the next example, next question. Write the following expanded forms as decimal numbers. So that means expanded forms are given to you. You have to write as decimal numbers. So first one is 800, see, plus 0 0.008 plus 0 0.0008. So how to add all this? So what we can do, we can convert all these numbers in like decimals by writing zeros to the extreme right to the decimal part. So 800 I can write like this, 800.0000, because here largest number of decimal places are 4, right? So 800.0000 I can write. Then next number is 0.0080, right? And the last number is 0.0008. Now you can add all these three numbers. After adding, we'll be getting 800.0088. So students, I hope all of you understood how to write the given decimal numbers in expanded form and vice versa. So try to solve remaining problems as homework. So students, today we saw what are decimals, right? Expanded notation for decimal numbers, what are like and unlike decimals, and how to convert unlike decimals to like decimals. Okay, I hope all of you understood all these points neatly.